The 1915 Çanakkale Bridge, with a span of 2,023 meters between the pylons, will be the longest suspension bridge in the world. An iconic new crossing in the Dardanelles Strait that will connect the cities Çanakkale and Malkara. Two enormous pylons will support the in total 3.5-kilometer long connection. These will be constructed on the massive caissons, which are installed with millimeter accuracy by Strukton Immersion projects. The Turkish-Korean joint venture Delim, Limak, SK and Yapı Merkezi contracted Strukton, a specialist for the flotation, transport and immersion of tunnels and caissons.
Directly from the start of the project, we are building a relationship with the client, and an open and transparent communication is very important for that. Big decisions have to be made in the beginning of the project, and therefore you have to have an open and transparent communication with your client. With that, we are building mutual respect and trust, and that will benefit the project for both parties.
Two caissons of 74 by 83 meters and a total height of 45 meters. The caissons are constructed in a temporary dry dock, approximately 4 kilometers from the installation location.
The caissons were built by the joint venture in about 9 months' time. The final weeks of the construction period we came to the site to carry out checks, but also to add already some equipment to the caisson. And we have connected the bollards of the caisson to the mooring wires of the winching system. After that, the dry dock was inundated, the caissons were floating. And while they were floating, we have secured the position safe. After that, the construction joint venture was able to dredge the trench necessary to float out the caissons to the mooring location. The float out was done by using tugboats and the winching system of the dry dock. We had to move the caissons about 400 meters to the mooring system of the wet dock. When they were safely moored, the construction team of the joint venture were able to continue the construction by adding the shafts. And we were able to start adding the expertise to the caissons, namely the ballasting system, to install that into the caissons. The size and the complexity of the caissons requires a very special ballasting system, an ingenious ballasting system. We have to pump 60,000 cubes of water in 29 clusters, and we know from our experience that the ballasting of such an object is essential to immerse the caisson safe to the seabed. Therefore, we have developed a manifold container per shaft cluster, which consists of remote-controlled valves, actuators, level transmitters, and a deballasting pump. We will feed the ballasting manifold through the floating hoses, which are connected to the ballasting vessel. And from the command unit on the ballasting vessel, we can control the water level on millimeter accuracy in each cluster of the caisson.
Through continuous monitoring of the survey systems, sensors and cameras, the caissons are installed at a 42-meter depth in a fully controlled manner. In 1 year of engineering, all the risks were calculated and mitigation measures were taken. Now, with military precision, the installation operation could start.
Well, one of the main challenges were the environmental conditions, and especially the current velocity, which was about 1.2 meters per second. So all the systems had to be designed on that high current velocity, such as the tugboats, the guide frames. and seabed anchors to anchor the tugs.
During the 72 hours installation process, 12 go, no-go meetings would determine the start of the next phase.
In projects like these, safety is the main topic and a topic that we are always focusing on. From the design phase, the work preparation, the execution and immersion, safety is always our #1 priority. We are working with a lot of disciplines together at the same location, at the same time. And all the guys know from their heart they have to take care of each other. Because we borrow the guys from the family and we want to give them back to the family.
Four tugboats transported the floating caisson to the installation location. The caissons were kept in position by connecting 2 tugboats to 15 tons anchors and 2 tugboats equipped with a dynamic positioning system, by which the influences of current and wind could be controlled.
By installing 4 special designed guide frames at the bottom of the Dardanelles Strait on pre-installed 45 meters long piles positioned in an L shape, we will be able to install the caisson at 40 meter depth with more accuracy than the given tolerance by the client of 20 centimeters. Per caisson we designed and built 4 specially developed guide frames, which made it possible to install the caisson at millimeter accuracy. Therefore, we equipped the guide frame with some unique tools like clamping jacks, hydraulic positioning cylinders, guide frames and a hydraulic valve block.
The 29 clusters are filled with water in a sophisticated order and ratio. A delicate process. It is an interplay between the water level in the compartments, the pressure in the ballast systems, and the roll and pitch of the caisson. The command team operates all systems remotely from a ballast vessel.
All the data from the caisson is coming in to the command unit. All data from the water levels of the water tanks. We have water level sensors inside the shafts, which measure the water levels in each of the compartments, the position of the caisson, the heel angles, rotation, all is coming in. And then we look if the caisson is in the right position and how we have to fill the tanks to lower it to the sea bottom. We lower the caisson until 1 meter above seabed, and then we are going to position it towards the guide frames. We use the tugboats to get the toe of the caisson against the guide frame. Then we lower it a little bit more and push out the jacks on the toe of the caisson to fine position the caisson.
Both caissons are placed with extreme precision on the bottom of the Dardanelles, only 10 millimeters from the target.
The entire immersion process is like a military operation and is meticulously prepared. The operation is described in a comprehensive work meta statement in which every step, risk and safety measure are identified and controlled. All systems are provided with backup measures to take over the processes in case the system fails. Apart from the technical expertise and the skilled process control, the human aspect plays a decisive role. The team members spend months intensively with each other to prepare all the resources required for the immersion operation. In the last couple of weeks before the start of the operation, they spend many hours, sometimes 7 days a week, to make sure everything is arranged to perfection for the complex job. During the 72-hour immersion process, the immersion commander is in charge. In addition to an experienced team, where everyone is fully attuned to each other, mutual trust and optimal cooperation are also required to successfully execute an operation of this size. Young specialists are also playing an important role in this. Their fresh look at technology contributes to the development of new techniques.
After installing the caissons, the ballast system was removed from the shafts and filled with water. After everything had been tidied up, Strukton handed over the caissons to the client. The client was now able to start building the 318-meter high pylons.
Every immersion project is unique and demands expertise and ingenious solutions. This is where Strukton Immersion project comes in. With our track record of international projects like the Busan Gotcha fixed link in South Korea, or the immersion of a tunnel element under the central station in Amsterdam, or the immersion of caissons of the Moser project in Venice. That makes us the leading company in our sector.
The opening of the 1915Çanakkale Bridge and the more than 100 kilometers long motorway and connecting road between Malkara and Çanakkale is planned for September 2023. Car traffic no longer has to use the ferry services over the Dardanelles. An economically important connection to a larger motorway network between Istanbul and Ankara, and the route to the south will then have been made.